Good morning, good afternoon, and good evening. This is the Oracle of Chinem Kutu, and welcome back. Today we have got a question that was sent to me, the first question that was sent to me by a student, a Matric student who is going to be writing the Matric exam this year. And the question, I presume, was in the trial examination paper of either 2019 or 2020. So the question here, we named it question 2, and the question reads, the equations of the graphs below are fx is equal to x minus 2 bracket squared, x minus a bracket, and gx is equal to mx plus 12. They are both passing through the points A, B, C. They are both passing through the points A and B. And then C and D, those 2 points, are turning points of the graph of fx. B is the y-intercept of f and g. So in other words, both f and g are passing through B, and at B, it's on the on the y-axis. That means x is equal to 0 there. So what you have to realize is that fx is actually a cubic function. If you expand this binomial expression and then multiply it by this monomial expression, you get a cubic function. And a is an unknown which is to be determined. And gx is a straight line and is equal to mx plus 12. M is the gradient. We do not know what it is, and we are supposed to determine it at some point. So you have to realize that gx is in the form of the normal equation of a line which is y is equal to mx plus c, where m is the gradient of the line, and the c is the y-intercept of the line. That means the point at which the line cuts the y-axis, which here is b. And also a is an x-intercept, because that is the point where the line cuts the x-axis and y is 0 there. So there are about 4 part questions to this question. The first part question says write down the coordinates of B. The second says determine the coordinates of A and D. And the third says determine the coordinates of C. And then the fourth says for which values of x will f be concave down. So the mark distribution is, for the third it's 5 marks, and the last is 3, the second is 3, the first is 1, which means it should be pretty easy to do that, a little bit more challenging to do that, and quite challenging for the 5-mark question, and then reasonably challenging for the last one. So in keeping with our naming convention, we are going to name this question the application of calculus 6, differentiation, and we will do it in parts so that the video is not too long. So part 1 will be answering questions 2.1 and 2.2. So let us start by writing our equations. Fx is equal to x minus 2 to the power 2 multiplied by x minus a, and we call this our equation 1, and this is our cubic function. Then the second equation is gx is equal to mx plus 12, and we can call this our equation 2, so that when we refer, we'll just say equation 2. And we realize here that we do not know the value of A. At some point we might need to determine it. We do also not know the gradient of the line, mx. So the first question, 2.1, wants us to write down the coordinates of B. The coordinates of B at B, which is the intercept, rather let us call it properly the y-intercept of both f, x, and gx has x coordinate equals to 0 there, because at that point we know what the value of x is. The y-axis is the equation of the line x is equal to 0. So we already know the x coordinate. What we need is to get the y coordinate. And for us to get the y coordinate, we look at our equations and see which equation can give us immediately the value of y by us substituting 0 into the position of x. And if you look at your equation 2, we do not know m, so if we substitute the value of x is equal to 0 here, we do away with the m. In other words, we no longer have to have a problem with the fact that we do not know m. So gx is equal to y is equal to m, the unknown, times 0, which is our x coordinate at B, plus 12. And therefore, we have y is equal to 0 plus 12, and our y coordinate of B is equal to 12, and therefore the coordinates of B are 0 and 12. And that is our solution to part 1. And that is the reason why this question is very simple. You can see from there, it is very clear as to why it is so. So now, quick things that we can see here is that at B, we know that x is equal to 0. So for our cubic function, x is equal to 0. So therefore, fx equals to y equals to minus 2 squared, because x is 0, and multiplied by minus a, because x is 0 there. So this is y is then equal to minus 2 squared is 4 times minus a, that gives us minus 4a. And having determined that y is equal to minus 4a at B, we know that the value of y at B is equal to 12. knowing that the value of y at b equals to 12, therefore we have at that point 12 is equal to minus 4a, and therefore a is equal to minus 3. We divide both sides by minus 4, which gives us a is equal to minus 3. And therefore, fx is in general equal to x minus 2 bracket squared multiplied by x, and we substitute for the value of a, which is minus 3, so it's minus a, it's minus multiplied by minus 3, which is the value of a, and that gives us a plus 3. You should realize how we got the plus 3. It is minus, and the value of a is minus 3. So it's a minus 1 times a minus 3 that gives us a plus 3. And we can call this our equation 3, and we already know what the value of a is, and we have that equation there. So also with the gx, we know that coordinates of b are 0 and 12, so we can get the value of m by saying gx is equal to 12 equals to m. This would not work because our value of m there is the value of x is 0, so that will destroy our m. So for the time being, it's okay. We can work with the equation 3. And for equation 3 to answer, so for 2.2, to write down the coordinates, determine the coordinates of A. If you look at A, A is the x-intercept of both fx and gx. So the y coordinate of A is 0. So we say, knowing the y coordinate to be 0 at A and using the equation that we have determined here of fx, where we have already determined the value of 3, it becomes very easy for us to substitute for the value of y, which is 0. And so using equation 3, we have 0 equals to x minus 2 multiplied by x minus 2 multiplied by x plus 3. So therefore, x is equal to 2 twice, and x is equal to minus 3. So a lot of students get confused as to how do you determine that. If we say y is equal to 0 and we have 0 there, that means any one of these brackets could be 0 at any point. So if it is this that is equal to 0, then everything goes to 0. In other words, we say x minus 2 is equal to 0, and therefore x is equal to 2. And the same applies to this. So when x plus 3 is the one that is equal to 0, if we multiply by these other two, they will also go to 0. So we say x plus 3 is equal to 0, and therefore x is equal to minus 3. And looking at the position of A, we can see that minus 3 is the suitable solution, and therefore the coordinates of A are minus 3 and 0. That means at that point x is equal to minus 3 and y is equal to 0. So if we look at D, we have already determined the two other roots of fx, and those two other roots are x is equal to 2 twice, and x is equal to 2 twice whenever you see a solution that is the same number twice. That means the graph just touches the x-axis at that point. So if you look at D, see y coordinate is 0, but then it just touches 2 at that point. We agreed that that point is minus 3 because of the way, the position where A is. So in this same token, we can also conclude that D is positive and it is 2. So therefore the coordinates of D are 2 and 0. And we have got both solutions for 2.1 and 2.2, and this forms part of the first part of our video presentation. The next part we are going to do 2.3, and at the moment, if you have got any questions concerning what we've covered here so far, please feel free to send me questions to my WhatsApp platform, which is +27 81 44 11 30.